Have you ever wondered how scientists came up with the molar mass of every single element in the periodic table? Well, that's exactly what we're going to be learning today in lesson 1.2 of AP Chem, Mass Spectra of Elements. So remember back to last video where we said we can find a molar mass of any element just by looking at the box on the periodic table. So for example, magnesium here, we can look right below it, we see 24.30. That means for every mole of magnesium, there's 24.30 grams of magnesium. So how do we find the mass of a single atom of magnesium? Well, that's just equal to the number of protons plus the number of neutrons. And we know this because the number of protons weigh about 1 AMU, and neutrons weigh also about 1 AMU. And although electrons are a part of the atom, they weigh basically nothing, so we don't include them in the mass. So the next thing we need to understand is that the number of protons determines the element it is. So as we notice on the periodic table, every element has a different number at the top, and they are in ascending order from left to right and then up to down. So what does this actually mean? This top number is the number of protons the element has, and if you change that number, then it's going to change the element. So we can't change the number of protons to change the mass. So what we can do is we could change the number of neutrons in the element, and that can change the mass, and those are known as isotopes. And as we can see here, Mg, magnesium, has 3 isotopes: Mg24, Mg25, and Mg26. Okay, so this is a mass spectra, and you're probably going to be given one of these on the AP Chem test on the MCQ section. So let's understand it. So first we have relative abundance in percentage, and this means how many times does this isotope occur in nature. And we can see here that Mg24 is the most abundant in nature because it is about 80% of the Mg atoms in nature. And then when we look at the bottom, we see atomic mass in AMU. And by the way, AMU and grams per mole are basically the same thing. They're a 1-to-1 ratio. So they're basically the same unit. And this just shows us the different isotopes, so 24, 25, and 26. And then we look at the bars. The bars are each isotope and its abundance. So as we can see here, Mg24 is most abundant, and Mg25 and 26 have relatively the same amount of abundance. So what do we need to do with this information? We can do two things. So the first thing to find mass is we're going to use the graph. So right here, all we're going to do is we're going to make a line from where the bar of 24 goes to the abundance. So if we make a line, we see it's about 80%. So what I'm going to write now is an equation. So we're going to write 24 times 0.80, and I just wrote it in decimal form because it's easier to put into a calculator that way. And then we're going to add 25 times point, if we make a dashed line across, we see it's about 0.1, and 26 is also 0.1. So we're just going to do 25 times 0.10 plus 26 times 0.10. And then this is basically like a weighted average, and that's how you find the average molar mass of magnesium. And so when we put this into our calculator, we actually get 24.30. And so on a multiple choice question, it would give you 4 answer choices, and it would be different elements. And you would have to match those elements with their molar mass just by looking at the periodic table, and then you'd match your answer to the one that's closest to the molar mass of one of the elements. So let's say it was like Na, Mg, Al, and He or something. So, and we found that the answer was 24.30 grams per mole, or AMU. You could write either one. And we match that to the periodic table. We actually see that it is exactly the same as Mg. So we could say that Mg was the answer here. And not all the time it's going to be the exact number, so it's not always going to be 24.30, and so it could be like 24.2, and you just have to find the closest one because Mg is still closer than Na to 24.2. So the second thing we can do with this information is we can find the number of neutrons in each isotope. So remember how the mass equals the number of protons plus the number of neutrons. So we are actually just given the mass for 3 of these isotopes, and we are given the number of protons. So all we got to do is just subtract. So we subtract the mass minus number of protons, and we get the number of neutrons, so 12 neutrons. And then here we can do 25 minus 12. We can get 13 neutrons, and then 26 minus 12, we get 14 neutrons. Okay, and that's basically it for mass spectra. You don't really need to use this equation. I didn't see it last year on the AP test, and I haven't seen it before, so it's just something to keep in the back of your mind, but it's just there to help you out if you need it. And that's it for mass spectra of elements. Thank you for watching.